Hi everyone, welcome back to Art of the Part. In this video, we're going to talk about more advanced features when looking at insert part modeling. In the last video, we talked a little bit more about the basic approach where you could separate your work holding pieces and you could design them independently and then bring them into the assembly afterwards. However, in this video, we're going to do everything inside the assembly and then reference the parent file, which will in this case be not only the blank softjaw, but the yield pop topper, because we want everything to be built around and react to the master file, the part that's being designed. So that said, I'm not going to save my assembly. I'm actually going to scrap this whole thing and start over here. So uh, if you saved yours before, that's fine. However which way that you want to approach this. If you want to make another like dummy copy or something like that, but I'm just going to close out. I'm not going to save. And then I'm just going to make sure that I have my blank softjaw open in the background. And we're going to start off very similarly to the last video, which was the simple approach, in that we're just going to file and then new. We're going to make a new part, insert the blank softjaw, and then make a front and a back file for it. So I'm going to go up here instead of going and creating geometry. I'm going to go over here to insert. We're going to find part. And then we're going to look for our blank softjaw style A. So I'll click on that. And just like before, we don't want to randomly click out here in 3D space and accidentally unlink our origin. So we're just going to hit the green check mark. We're going to standardize the units, locate the part, and then I'm going to hide my planes over here on the left side. Likewise, you can just individually click the planes and then hit the hide, which is the little eyeball here, whichever way that you want to do it. We're going to File, Save As, and then I'm going to go into my SoftJaws folder and then SoftJaws A-1. I'm going to overwrite my front and my back, even though I did all the work on the simple one before in the last video. We're just going to overwrite 1F, we'll hit yes, and then I'll file Save As, and I'll overwrite 1B as well, and I'll hit yes. Okay. Now we're going to, instead of going through and adding all the geometry like we did in the last video, we're going to open up the assembly first and then pull in these parts and then start designing inside the assembly. So let's go ahead and go File, Open, and just like how I was explaining in the last video, you should have a file folder that you can download from the Google Drive. It's a zip file of the 5-axis riser and vise. Just look for that assembly file type, 5-axis vise and riser, and then click Open. Likewise, we have all of our different configurations that we can select through. So I have my hard jaw with parallels, and then my hard jaws with the stop and parallel. I don't necessarily need any of these components active, so go to the hard jaw default configuration, and then we're going to add a new configuration for soft jaws, and then we'll hit the green check mark. And just like how I did in the last video, I can click on these components and I can choose suppress. Likewise, you can always go over here to the feature tree and then you can select these components out of the feature tree, and then I can choose suppress in this location as well. But either way will work. I'm just trying to get rid of those components within the new softjaw configuration within the assembly. And then I'm going to start inserting or importing my two softjaw blanks for the front and the back that I just made a couple steps ago. So here we'll go to Insert Components. We can go Browse. I can find my softjaw folder, my softjaw A1, and then I can pull my front and hit Open, and then I can pull my back and then hit Open, and then I'll put that back there. And once again, we'll mate these into place like we did in the previous video. So mate, I will grab the through hole to this hole. Then I'll grab this hole to that hole. You can check mark, and then I can pull this part away, grab that face to that face, and then we'll do the same thing on the back side. Oops, I grab the counter bore, grab the through hole to this hole, green check mark, this hole to that hole, and then we'll hit the green check mark, and then we'll pull this apart a little bit, and then we will grab that face to that face. And I know this from the previous video, but we now have to apply a distance between these two parts. And if I open up my drawing here of the assembly, I notice that I have a space or a gap where the gauge block is going to go when I end up machining this part. or machining the soft jaws. So I know that that value is going to be 0.03125. So I can go ahead and choose my mate selections, grab that face to that face, and then I can give a distance mate, which is going to be the two arrows pointing in opposite directions with lines on either side of them. We'll go mate, and then we'll make that 0.03125. And I want everyone to just understand where that dimension or that measure distance mate is, because we're going to be using it for a handful of steps coming up here. So just make sure that whenever you select your two faces that you want to be a distance from each other, that you know where this distance mate is located. Again, it's the two arrows pointing in opposite directions with a side or a line on each side. And then we can hit the green check mark after we apply the value of 0.03125. So now I have my soft jaws in place. It's very similar to the last video. And here's where we're going to start to differentiate. So now, instead of drawing our dimensions independently and drawing our geometry independently, we're going to actually import or insert the yield pop topper and use that as our parent or a reference to build our geometry around. So now we can go into the assembly tab and we're going to select insert components, just like what we did with these two soft jaws. And we're going to look for our yield pop topper. So locate that yield pop topper and we're going to hit open. And we're just going to drop it out here on the left somewhere. We'll just make it easier for us when we're mating things together. So the first thing that we want to do is we want to mate and orient this part in such a way where this face is in line or parallel to this face, but a distance down, which is right here, this value of 0.34 4, or in the fractional value is 0.34375. So what I'm going to do is I'm going to hit the mate command, and just like I was saying, we're going to use this distance mate quite a bit now. So we're going to select this face here, and then we're also going to select this face here. And that's going to temporarily make it coincident, which is fine, but we're just going to then make this a distance now. So it's actually going to give it a distance of like 2 inches in my case. We can always like reposition this so it's like more centered into the part. But this value is going to be 0.34375. And then just make sure that, when you center it, that you're going the right direction. So mine is going up. I might have to actually flip my direction so that it's going into the part. And then green check mark. And then again, we just got to center it so that it's in the part. It's actually going into the part somewhere. All right. Now we're kind of turn up the difficulty a little bit here. We want this part to be centered somewhere and somehow. And the way that we can access that is I know that I have an origin point located right here, which is in line with this quadrant edge. And I want that quadrant edge or that origin point to be a distance from this edge, because I can see that here on this drawing. There's a distance of 0.5623 from this flat face to that flat face. So what I'm going to do is I'm going to choose a point or a face inside of this part. And just like how we can go and access other, pieces of geometry in this window here where it says 5-axis vise and riser, I can then open up or expand the geometry itself in a specific part. So inside of this 5-axis vise and riser here, up here, I can hit the drop down or expand window and locate my yield pop topper. And I can once again hit that drop down or that expand arrow, and I can find a piece of geometry that is in line with that quadrant edge. So I can hover over some of these different components here. So I got my front plane, top plane, and I have my right plane. It looks like the right plane is in line with the origin. But I'm just going to use the origin because I know that's exactly dead on 0, 0. So I'm going to select my origin inside of my yield pop topper. And you're going to notice that I have a set of front plane, top plane, and right plane for my assembly, but then I have my set of front plane, top plane, right plane for my part. Same thing with the origin. There's an origin of the assembly, and then there's an origin of my part. Make sure that when you are applying this mate that you are selecting the origin of the part. So we'll select the origin here. And then that origin is then going to be mated against this edge here on the soft jaw. So right now it's coincident, it's collinear with that face. What we're going to do is we're actually going to select this to be a distance. And just like how we did before when we were applying the distance between these two soft jaws and then the bottom face and the top face of this, we are going to select this and be 0.5625. So I'm giving a distance mate from this edge to that quadrant face or the origin. And then I'm going to hit the green check mark. So before I exit out of this mate function, I know that I've applied 2 mates. I need 3 mates to restrict my degrees of freedom. And you can see that when I grab this part, it's going to start to wiggle around. What I want to do is I actually want to give a value, if you look here on the print, from the top edge of the pop topper to the bottom edge of the back side of the jaw. And that value is represented right here. That is a value of 0.0625. And you might remember that from when we were drawing the soft jaw on the back side for the more simplistic video. But what we're going to do now is we're actually going to select this face here. So it's the top edge of the yield pop topper. And then we're going to select the bottom face of the back side of the jaw. So it's going to be this face right there. And what that did again is it put it in line, and we're just going to give a value of offset or distance to make it go in a specific direction. So I'm going to choose distance, and I'm going to give a value here of 0.0625. And it went down into the front soft jaw, and we want it to actually go into the back soft jaw. So I just got to flip my dimension once again and then hit the green check mark. So I see my 3 mates here on the left-hand side. I know my part is fully defined and it's restricted in its degrees of freedom because when I click and drag on it, it's not going to move around anymore. And then I'm going to go ahead and hit the green check mark. So now what I've done is I've positioned my part where I want it to be when I start cutting my soft jaws. So I'm going to use this as like a parent reference, and this is really good because I know exactly where my geometry is and what I have to design around, instead of the other way in the simple video where I'm kind of doing it independently and I don't exactly know where all my geometry is. So in this instance, I'm going to start using this new feature, this new function called edit component. And this is a very powerful tool whenever you're using assemblies and designing within assemblies. So the way that I like to explain this is I want you to always understand where you are within the assembly or the part. And there's a couple checks that we can go and look against. And the first one is that we see the 5-axis vise and riser file save name up here. And that is just going to be your typical assembly file. And we know that because down here at the bottom, we also see editing assembly. If we're editing a part inside of an assembly, this will then change to become editing part, and up here it'll say the name of the part editing within this name of the assembly. And the way that I like to think about editing parts within assemblies is think of yourself inside of a house. And all the different components are the different rooms within the house. So the assembly is the house, the rooms are your different components. If I want to go into a new room and start making changes in that room, I have to make sure that I open the door to get inside of it. And the way that I can open the door and get inside the room is by selecting the room or the door, or sorry, selecting the room or the component that I want to be in. And I now get this option to edit component. So I want to start making changes to this front jaw here. And what I'm going to do is I'm going to select it, and I'm going to open the door, and I'm going to see this option here, edit component. So when I choose edit component inside the assembly tab, I'm now editing the soft jaw within the assembly. And you can see that again down here, I have a note that says editing part. I also have soft jaw A in 1F, or sorry, soft jaw A-1F in the assembly itself. So those are 2 ways that I can check against and make sure that I'm editing the component. Likewise, there should be another check here in the feature tree, and whatever part that you're editing should be highlighted in blue. Not as obvious as these 2 other methods, but still another good check in seeing where you are. So what this is allowing me to do is I'm treating the part file as a part file inside the assembly itself. I don't have to go back and make changes and put my geometry and dimension things that way. I can actually start applying some sketches onto this part and cut while still looking at all of the different components within my assembly, which is very good. So let's go ahead and start editing this part, or start creating the geometry of the soft jaw that we have to hold this yield pop topper. So I'm going to select this top face here, and then I'm going to choose sketch. And again, make sure before you go ahead and start applying this geometry that you are in fact editing a part, that you are the softjaw A-1F in the blank softjaw assembly. And then you can also see that this file or this part or component is highlighted in blue in your feature tree. So let's go ahead and right click on that face and then choose to start a sketch. And what we're going to do is we're going to start creating geometry around this component. And instead of having to like memorize where, I have to be around and certain dimensions that I have to keep in mind, I have a really good reference now to just start drawing whatever geometry that I need. So for instance, I can go ahead and, make my first line coincident with that edge, and then I can start creating geometry around this part as I need. And you're going to see and I'm in a pretty good spot. And once again, I have to make sure that I'm closing off my geometry if I want to produce a cut here. Right now it's open-ended geometry. It'll produce a thin feature. So let's go ahead and close it, and we can see that I have this nice watertight piece of geometry that I can design around. I'll hit the green check mark and get out of that line. And once again, a couple different paths you can take here. If you wanted to, you could go ahead and start drawing the or dimensioning things out per the drawing. But I think it's going to be more helpful for us if we start linking our geometry to the other parts of the components that are already existing within the assembly. So instead of going into the smart dimension and smart dimensioning everything out, let's go ahead and start referencing the lines or components that are existing within our part file of the yield pop topper. And you can see, depending on what version of SolidWorks that you are in, or if you've done these settings before, you might see something that looks like this, where if you went to go edit the component, everything turns transparent. That's fine. That's all that's saying is that all these components that are transparent are not being edited or they're not being worked on, whereas the one that is fully opaque here is the one that is being edited or worked on. If you want to toggle back and forth between these, you can go into the Sketch tab or in the Feature tab, no matter which one, as long as you're in the Edit component. There should be an Assembly Transparency option. You hit that, there's a drop down. You can choose between opaque or forced transparency. And typically, whenever you want to be using or referencing geometry, you don't want to see the transparency because you're not always going to be able to pick all these edges. For instance, like if I try to hover over this yield pop topper, I actually do not get the ability to select these edges. However, if I do change this to opaque and I hover over these edges, I do have the ability to actually select them. So if you are having trouble with that, just make sure that you are toggling between this assembly transparency and choosing the the opaque option if you want to actually grab these edges. So that said, I can actually grab or hover over this edge here, and I can make it tangent with this line that I just made. Likewise, I can make this bottom edge tangent with this line here, or this arc there. So I know that I've created a nice snug pocket for that part to slip into. Same thing, I can grab this edge. Don't want to grab the chamfer, but the flat edge there. Grab that and make it collinear. And all I'm doing to apply these relationships, I'll go back a couple steps, is as long as I have one of the lines selected, I'm holding down the control key, and I'm grabbing another one of these lines, I get the option to add relations. So I can make that tangent, I can hit escape a couple times, grab that line and hit this arc and make it, or that edge rather, and make a tangent. And then same thing up here, I can grab that line and that line, I can make them collinear, and then I can grab this line and that line and make it collinear. It could be tempting. We could easily just make this line and this line collinear, but I do like to always leave a little bit of gap in my soft jaws just in case that there's any variation in my parts. So in this instance, I just made it symmetrical from one side to the other. I know that this value, and you can see it here on the print, is 0.5625. So I'm going to actually give a hard dimension here from that edge to that edge, and I'm going to make that 0.5625. And then I also should probably include a hard dimension here too, because I don't want to be holding on to these edges because there's only one point of tangency. I'd rather take advantage of the flats. So in this instance, I'm also going to use this 0.46875 as my hard dimension from this edge to that edge. And I'll make that 0.46875. Once again, I'm going to have to make this edge and this edge collinear. So I'm going to grab that, hold down the control key, and then grab that edge and make it collinear. And then I know that this angle here is 45 degrees. So if I go over here to Smart Dimension, I can make that 45 degrees. And then depending on which way you want to approach this, you can just as easily grab these points and then like make them intersect at these quadrant points and then apply your radii afterwards. Or, for instance, you can continue to follow along with this ordered dimensioning system. And I know this, and I can just put these dimensions in really quick. But it's really helpful because if I want like a nice snug fit here, I can put a value of like 0.125, and I can grab this, and I can make them, tangent to each other. And then that edge would be like right in that corner, and it would be really snug and hold that in place. However, I'm going to leave a little bit of space there and then use a smaller radius instead. So I'm going to come back up there and reconnect those. And I know that from my drawing, I wanted a typical radius of 60 thousandths or 0.63 in all these corners. So I'm going to just dimension all of my intersection points and then put my radii in afterwards. So I know that this value here, you can always reference the blueprint, is 0.55. I know that this one to here is 1.0875. This value to that edge is going to be 2.0125. And then this value to that edge will be 2.203125. All right. And then using my sketch fillet command while in the sketch tab, I can select the sketch fillet and I can change the default value to 0.0625. And I'm just going to grab all these corners and make sure that I'm applying it to all these edges so it becomes typical. Again, I do not want to select this top edge there and that top corner there and that top corner there because we're actually going to mill across it and it'll be wiped away anyways. So we'll hit the green check mark, and then I'm going to go ahead and select features. Oh, make sure that you exit the sketch when you're in this assembly here. Oh, sorry, exit out of that that sketch fillet. That was my problem there. And then go over to features, and then we're going to select extrude cut. And then inside extrude cut, we are going to give a value here. And if we wanted to, we could find the value by making it like up to next or up to face, or sorry, up to vertex or up to face. But I don't want to have to change my transparency all going back and forth. I'm just going to use this default value of 0.34375. So I'm going to go 0.34375. However, if you did want to like ensure that I was going up to like that edge, I could always go in here and force transparency and, for instance, go and edit that feature. And instead of it being blind, I could go to up to surface and I can just grab, and that might be the problem too, where I'm not even able to grab that vertex there. I can grab that edge of the part so that if the part ever grows or shrinks, my cut or my offset will then shrink or grow with it as well. Again, you can always default to just putting in that value, that 0.34375. Again, more advanced approach where I had to change the transparency, and then I went to up to vertex for my extrusion or my cut extrusion, and then went to that edge. Not entirely necessary, just something that is available and out there. If I did want to then, start referencing these edges again, I'd have to change my assembly transparency back to opaque. Again, I have to break my edges here. I'm just going to go and make a chamfer. If you look here at this blueprint, I have a chamfer 1/64, 45 degree typical. So that's already defaulted back into that. And I'll just go ahead and select that edge and then hit the green check mark. Okay, so before I exit out of this room or exit out of this component and go back into the assembly, I want to make sure that the changes I made are saved to that particular part. Once again, I should see up here that I have softjaw A-1F in the assembly, and then I'm editing the part. Make sure that you save this, so you can go to File and Save. so that those changes are applied. Now I want to exit out of this room and I want to go back into the assembly, or I want to exit out of this component. And what I'm going to do is I'm going to select now edit component in the top left-hand corner. So I'm exiting out of the room, going back into the house, and then now I have the ability to start editing other components or going into other rooms and working on them. So I want to go ahead and make changes on this back soft jaw, and I'll just follow the same exact procedure. So we see up here, I have 5-axis vise and riser. I'm editing the assembly. I'm not inside of a component, so if I start doing sketches, I can't actually cut into the part and it will not apply. So I have to select the part itself, and then it's actually going to highlight here into the feature tree. And once again, if I want to open that door and get inside that part or get inside that room, I have to choose edit component. So select edit component. You'll notice that I'm working on softjaw A-1B within the assembly, and then now I see editing part there on the bottom right, and then I should see a softjaw A1B that is highlighted there as well. And I can access geometry and expand geometry by hitting the arrows here, and I can close out of this A-1F. I don't need to see that geometry anymore, and now I can start working on the part here. So I'll select on that face, I'll start a sketch, and then I can actually reference geometry from other pieces that I just made. So for instance, I know where these extents are going to be. I don't have to smart dimension it all out anymore. Let's go ahead and just start a line, and I'll make it coincident with this edge, and then I will just do a rough outline or profile here, and I will just make it inline or collinear with this. And once again, I'll make this, once I'm holding down the control key, selecting an edge, or selecting a line and selecting an edge, and then I get the options while still holding down the control key to add relations. And I can do the same thing here, where I can grab this top edge, hold down the control key, grab this edge, and then I can make it collinear. And I already know from the last time that if I try to apply a sketch fillet in those corners, they will not apply because they are the exact size and would wipe away this line here. We can always just extend this out and go a little bit further. And then we can go ahead and connect those lines, make this horizontal. And I can just give a value. It doesn't really matter what that smart dimension is. It's going to be like 0.125. That's fine. Because now when I put my sketch fillet in those corners, even though that it's like running up into that quadrant or that tangent point right there, or the intersection, it has enough room where the line isn't going to be eliminated. So we're going to hit the green check mark, and then I can go ahead and go back into features, and then I can go extrude cut. And again, I can type in the value 0.34 375, which is the value that's shown right here on the drawing. Or again, I can go up to vertex and select one of these edges, or in this instance, I can actually go up to surface, and I can select that face right there, and then hit the green check mark. And now I can go ahead and select my chamfer and chamfer that edge as well. So it's very powerful in the fact that I can actually go in and make all these changes within the assembly and can see if I need a little bit more clearance or a little less clearance, or I may need a bigger flat. And I don't have to keep jumping back and forth between the part level and then the assembly level. I'm doing this all at the assembly level just to add a part view. And that's all within the edit component. So after I've applied those changes onto the backside, make sure that you are saving. So file, and we'll go ahead and select save. And then if I want to exit out of this room or exit out of this part and go back into the assembly itself, just hit edit component, and again, see where it says editing part and soft jaw within the assembly. We're going to hit edit component. It's going to bring us out. It's going to be back here in the assembly, and now I see my 5-axis vise and riser. And that is just the more advanced approach in linking all these parts together. And this is very helpful because if I wanted to make a change, for instance, on this part, I maybe want to make it thinner, and I maybe want to change this arc back here. Let's see what would happen if I went and opened this part like I did before when we were talking about the theory of this. So I go to open part, and instead of it being, let's say, this radius here is going to be 437, or that diameter rather is 437. If I wanted to change that, and that was going to be, let's say, a 1/2 inch, it grew a little bit, and I exited, and then I tabbed back over to the part, or the assembly. It's going to say, hey, the models have changed. Yes. You see how it moved and updated my work holding accordingly? So it's just really reactive in the sense that as long as you're linking these parts all together, you're going to see the parts change in a much quicker and rapid approach. And it just makes designing work holding and designing parts, especially if they are multiple components that have to work with each other, a lot easier, especially if you're referencing everything like this. And there's a time and place for referencing and not referencing. Obviously, if I wanted to make sure that like this work holding was never going to be changed or linked to anything, maybe I'm not going to link it to another component. But this is just a good example of how you could approach the insert part modeling from a couple different ways. So I'm hoping that you gained an appreciation seeing it from both the basic approach as well as the advanced approach and seeing all these different methods. The way that it varies again is by in the basic, we're just doing it all independently, and in the advanced, we're doing it all in the assembly using this edit component feature. So I'm going to go back here and change this value back to its original state, and then toggle back over here, and then let's see, that part just disappeared on me. I think I accidentally hit it, show, and then same thing with the bottle opener, show. All I want you to do now is, if you didn't make any changes, that's fine. I just was showing you an example there. Go ahead and save this, and this should be ready to be pulled into drawings, and you can start making your exploded views and everything like that. Again, if you are having trouble locating those exploded views, I should have a video on it, but it's over here in the assembly tab. And then if you go over here to exploded view, right here in the middle, I can click on that, and I can start selecting these pieces of these components rather, and then just dragging on these arrows and then hitting done with every one of the steps, and then grabbing the next one, and then moving on, so on and so on and so forth. Again, all of those will be linked inside of your configurations. If you have to make changes on them, just find the configuration that it's linked to, right click on it, and then edit feature, and then you can edit the steps that way. But I'm going to end the video there, and then from here we can start importing this entire model back into Mastercam for programming, or into a drawing file to make drawings itself. So I'm going to collapse that and then save it, and then I'll catch you on the next one.